Hi class, how are you today? That's the inverse of normal. The learning target for today is to be able to find the area under any normal curve. Year 3, if you can find the area under any normal curve. 2, you can find the area under a standard normal curve. 1, you can convert raw stores to z-stores and vice versa. And 0, you cannot convert raw stores to z-stores and vice versa. Notice that a 2 this time was a 3 last lesson, and a 1 this time was a 2 last lesson. Let's get started. Section 6.3, Areas under any normal curve. Focus points. Compute the probability of standardized events. Find a z-score from a given normal probability using the inverse normal. And use the inverse normal to solve guarantee problems. Normal distribution areas. In many applied situations, the original normal curve is not the standard normal curve. Generally, there will not be a table of areas available for the original normal curve. This does not mean that we cannot find the probability that a measurement x will fall into an interval from a to b. What we must do is convert the original measurements x, a, and b to z-values. So you're not going to have the standard normal curve that has all the z-stores. You're going to have raw stores that you have to turn into z-stores. How to work with normal distributions. To find areas and probabilities for a random variable x that follows a normal distribution with mean mu and standard deviation sigma, convert x values to z values using the formula z equals x minus mu over sigma. Then use table 5 of appendix 2, or what's in the beginning of your book, to find corresponding areas and probabilities. So we've already dealt with this in the last section. So we're just dealing with it more again. We're going to use it more in what we're doing. Let x have a normal distribution with mu equals 10 and sigma equals 2. Find the probability that an x value selected at random from this distribution is between 11 and 14. In symbols, find p of 11 is less than or equal to x is less than or equal to 14. Since probabilities correspond to areas under the distribution curve, we want to find the area under the x curve above the interval from x equals 11 to x equals 14. To do so, we will convert the x values to standard z values, and then use table 5 of appendix 2 to find the corresponding area under the standard normal curve. We use the formula from before to convert the given x interval to a z interval. So for z1 we have 11 minus 10 over 2, which is 0.5, and for z2 we have 14 minus 10 over 2 is 2. We're using mu is 10 and sigma is 2 for both, and x is 11 for the first one and x is 14 for the second. The corresponding areas under the x and z curves are shown below. So here we have the standard normal curve. Here we have it as our x curve. It's a bit more spread out because it has a larger standard deviation. And it's at 10 instead of 0 because that's where the mean is. And the blue is the area under the curve. From that figure, we see that the probability that x is between 11 and 14 is the probability that z is between 0.5 and 2. So we do the probability of 2, the probability that z is to the left of 2 minus the probability that z is to the left of 0.5, which on the table gives us 0.9772 minus 0.6915, which gives us 0.2857. The probability is 0.2857 that an x value selected at random from a normal distribution with mean 10 and standard deviation 2 lies between 11 and 14. Inverse normal distribution. Sometimes we need to find z or x values that correspond to a given area under the normal curve. This situation arises when we want to specify a guarantee period such that a given percentage of the total products produced by a company last at least as long as the duration of the guarantee period. In such cases, we use the standard normal distribution table in reverse. When we look up an area and find the corresponding z-value, we are using the inverse normal probability distribution. Magic Video Games Incorporated sells an expensive video games package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the computer fails during the guarantee period. The research department has done tests that show that the mean life for the computer is 30 months with standard deviation of 4 months. The computer life is normally distributed. How long can the guarantee period be if management does not want to refund the purchase price on more than 7% of the Magic Video packages? Let us look at the distribution of lifetimes for the computer control system and shade the portion of the distribution in which the computer lasts fewer months than the guarantee period. So what we want is 7% less. So less than 7%. So since we want less than 7%, we want just this blue area. So we want to see what is the X score when it's 7%. If a computer system lasts fewer months than the guarantee period, a full price refund will have to be made. The lifetimes requiring a refund are in the shaded region in the figure. This region represents 7% of the total area under the curve. We can use Table 5 of Appendix 2 to find the z-value such that 7% of the total area under the standard normal curve lies to the left of the z-value. Then we convert the z-value to its corresponding x value to find the guarantee period. We want to find the z-value with 7% of the area under the standard normal curve to the left of z. Since we are given the area in a left tail, we can use the table directly to find z. The area value is 0.0700. However, the area is not in our table. So we use the closest area, which is 0.0694, and the corresponding z-value of z equals negative 1.48. So this is the table that's in Appendix 2 or just in the front of your book, like we've been using. And so it's somewhere between negative 1.48 and negative 1.47. And we want it less than, so we're going to have to stick with the negative 1.48. To translate this value back to an x value in months, we use the formula that we learned last time of x equals z times sigma plus mu, which is negative 1.48 times 4 plus 30, using the standard deviation of 4 months and the mean of 30 months that we were given previously, and that gives us 24.08 months. So from that, we can decide that the guarantee should be no more than 24 months. Now time for the sponge activity. Make sure to use a normal distribution table for these problems. As I've mentioned before, it's in your book in the front. Just use that. Number 1, the number of calories in a salad on the lunch menu is normally distributed with mu equals 200 and sigma equals 5. Find the probability that the salad you select will contain more than 208 calories and between 190 and 200 calories. And then number 2, find the z-value such that 85% of the area under the standard normal curve lies to the left of it. That's it for the lesson. Once again, please make sure to take notes on the entire lesson Submit everything to Google Classroom, and have a good night.